Alright, this video is about average rate of change, and so what we're looking at is just any function which does not have to be a line. It can be any function at all. So if you look at this graph, this blue curve is our function f of x. And if I want to know the average rate of change between two x coordinates for that graph, then what I'm essentially doing is I'm finding the y coordinates at those x coordinates. Okay, so whatever that x coordinate is, I would plug it into the function and get that y coordinate for both of those. And then what I'm doing is essentially drawing a straight line between those 2 points. Okay, so this line is not part of my graph, right? It's not part of my function. My function is this curve. But this line helps me to figure out what the average rate of change is between those 2 points. And so what we're essentially doing is we are finding the slope between those 2 points on that graph. Okay, so we can't actually find the slope of this curve, right? Because I mean it's not a line, so I can't find the slope of it. That doesn't make sense. So what I do is I take those 2 points and draw a straight line through those, and then find the slope of that line, and that is the average rate of change. So if you are given a function, so number one, we have a function f of x equals x minus 3 squared. I want to find the average rate of change between x equals 4 and x equals 7. Well, the first thing I need to do for both of these is find what their y coordinate is. So if I plug in 4 into the function, that's going to be 4 minus 3 squared, which would be 1 squared, which is 1. So what that essentially tells me is that the point 4 comma 1 is on this graph. Okay, and then I'm going to do the same thing with 7. F of 7 is 7 minus 3 squared, which is 4 squared, which is 16. So again, that tells me that I have the point 7 comma 16 on this graph. Okay, then to find the average rate of change, I'm doing f of b minus f of a over b minus a. So in this instance, that's going to be f of 7 minus f of 4 over 7 minus 4. F of 7, we just evaluated that, that's 16. So 16 minus f of 4, we evaluated that, that's 1 over 7 minus 4. So that's going to be 15 over 3, which is 5. So our average rate of change between 4 and 7 for this graph, x minus 3 squared, is 5. Again, what that essentially means is if I look at these 2 points on this graph, this thing is a parabola, by the way. If I look at those 2 points on that parabola and I draw a straight line between those, that line will have a slope of 5. That's what we're looking at. Number 2, if an object is dropped from a tall building, then the distance it falls after t seconds is given by the function d of t equals 16t squared. Find its average speed over the interval from 1 second to 5 seconds. So again, it's kind of the same idea. I need to figure out essentially d of 5 minus d of 1 over 5 minus 1. Okay, so it's just average rate of change. The y values at those times, which is the distances in this case, the difference in those y values over the difference in those x values, which is our time in this case. So what I need to do is figure out what d of 5 is. So I need to do 16 times 5 squared. Okay, so pull up Desmos here. So that's essentially 16 times 25. Which is 400. So again, d of 5, if I plug 5 into this function, I get 400. Minus d of 1, if I plug 1 into that function, we get 16 over 5 minus 1. So that's going to be 384 divided by 4. Okay, so if we do 384 divided by 4, that gives us 96. So we have an average rate of change of 96. Now, since I know these, this is a word problem talking about a specific thing. Now it doesn't tell me what my unit for distance is. It just says the distance it falls. So if maybe we're talking about feet here, if this is in feet, then I can say that this is an average rate of change of 96 feet per second, right? Now that would have to be given. I need to know that, but that's essentially when you're doing an average rate of change, you're finding a slope. So it's something per something. So in that case, feet per second. Okay. This last one talks about the average rate of change of specifically linear functions. So if I have a line, this thing is a line. This is mx plus b. If I have a line and I want to find the average rate of change, I'm going to do this without using numbers. So I'm going to go between two x values, and those x values are a and a plus h. So what I'm essentially doing here is I'm doing f of a plus h minus f of a, and I'm going to divide by the difference in those x values, which would be a plus h, and then minus a. So f of a plus h, so that means I'm going to take a plus h and plug it in for the x. So it's going to be 3 times a plus h minus 5. And then I'm going to subtract from that f of a, which means plug in a to this, which is 3a minus 5. And I'm going to divide that by, I've got a plus h minus a. Well, those a's would cancel each other out, so I would just have h on the bottom. Now I'm going to distribute, and some things should cancel here. So I'm going to get 3a plus 3h minus 5 minus 3a plus 5. Make sure that it's distributed there as well. All over h. The 5's will cancel. The 3a's will cancel. We're left with 3h over h, which is 3. So the idea here is that if you are doing average rate of change of a linear function, it will always be equal to the slope of that line, which is 3. Right? So that should make sense. If you take 2 points on a line and draw a straight line between those 2 points and then find the rate of change or slope of that line, that's just going to be the slope of the original line. So that's what that tells us. Okay, so average rate of change, essentially just find the 2 points and find the slope.